In this video, we're going to learn more about perpendicular lines and what we have when there's perpendicular lines mixed with some other angles. So first off, if we have two lines that intersect to form a linear pair of congruent angles, then the lines are perpendicular. And if you see my picture, you can see that we have two angles right here that form a linear pair, and they are congruent. So therefore, that the only way that's going to happen is that they're the same size and they make up a straight line, as if this is 90 degrees, so it's perpendicular, so if they're both 90 degrees. The next one is if we have two lines that are perpendicular, then they intersect to form four right angles. If we use some of the reasoning that we knew from before, that if we have just intersecting lines and say one was 90 degrees, by our supplementary definition or linear pair, we knew that angle 2 then would have to be 90 degrees, and so forth all the way around. And 1 and 4 would be vertical angles, so they'd be congruent, and so would 3 and 4. So we could have figured that out anyways, just we didn't necessarily need this specific definition, but this would work the same way. So we have an example. If we have this picture right here, and it says that AB is perpendicular to BC, so I drew my square around it to show that, what can you conclude about angle 1 and angle 2? And so what we can conclude about those two is that they will both need to be 90 degrees. We also know that we could say that the angle 1 is congruent to angle 2 because they're both going to be 90 degrees. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. If you see the picture, if our adjacent acute angles, if you notice them right here, are perpendicular, so they create a 90 degrees, then they are complementary. So the next one, I want you to try this out. So knowing the different pieces that we have that I've shared already, if we know that angle ABC is congruent to angle ABD, what can you say then about angle 3 and 4? So something you can say about that. Since I know that angle 3 and 4 are then going to be congruent to the other side, that the only way that's going to happen is if they are perpendicular. So if AB is perpendicular to CD, but that's not saying anything about the angles. So the angles themselves are going to be complementary. Next, the perpendicular transversal theorem is saying that if a transversal, so you look at my picture over here, this J, line J is my transversal. If that is perpendicular to two parallel lines, then it's also going to be perpendicular to the other one. So we can apply then if it's perpendicular to one of the parallel lines, then we know it's going to be perpendicular to the other side. The next one is that lines that are perpendicular to a transversal theorem. So in a plane, if two lines are perpendicular, so if you notice the M and N are perpendicular to the same line, so they're perpendicular, both perpendicular to P, then they're going to be parallel to each other. So M and N have to be parallel to each other. So in a question that will be pretty typical in this section and on the test is you need to figure out if there's any lines in here that are parallel and why. So in this one, if we see two perpendicular angles that are side by side, it's like this last one up here. So if two lines are perpendicular to the same line, then they have to be parallel to each other. So these two right here tell us that the line S and the line T then have to be parallel to each other. It also tells us with these other ones side by side, these two right angles, that now P and Q are also going to be parallel to each other. So to figure out if line B is parallel to line A, so if B is parallel to line A, we need to see two lines that we need to see both of those lines that are perpendicular to the same line, and they are perpendicular to the line D. So yes, A and B are going to be parallel to each other. For the same reason, we know then that lines C and D will be parallel to each other, and because all four of these are parallel to each other, we've got 90 degrees, 90 degrees, and 90 degrees, that means that right here is also going to be 90 degrees. So this next one would be yes, that they are going to be perpendicular, and it's because all four of those angles are going to be perpendicular. The distance from a point to a line is talking about the length of the perpendicular segment from the point to the line. So it's the shortest distance between two lines is if you use the perpendicular line. So if we had a line segment like this and a line segment like this, the shortest distance between two of them would be the perpendicular distance. So the perpendicular line. So in number 4, this is something completely different, but I would like you to try. This is a typical question you're going to see as well. You might want to put a big star by this. So if RS is perpendicular to ST, that means that this is 90 degrees right here. That means this is 90 degrees with those two together as well. So we know that they are going to be complementary. And we know that complementary means that our angles are going to add up to be 90 degrees. So we need to add those together to equal 90 degrees. So go ahead, push pause, work out your equation, and solve for x. Alright, so the setup you should have used was a 3x plus 10. Sorry, this is a little sloppy, goodness. And then plus the x of the other angles. You're adding the two angles together to equal your 90 degrees. So then you can combine your x's together, so you'd have 4x plus 10 equals 90 degrees. And then you can subtract your 10 from both sides. So you should get a 4x equals 80. And divide both by 4. So that's where we know that x is going to be 20 in this question.